Let's look at this problem called gas station. Let's have a read. There are n gas stations along a circular route where the amount of gas at the ith station is gas of I. You have a car with an unlimited gas tank and it costs cost of I of gas to travel from the ith station to the next station, and you begin a journey from an empty tank at one of the stations. Given two integer arrays gas and cost, return the starting gas station's index if you can travel around a circuit once in the clockwise direction, otherwise return -1. If there exists a solution, it is guaranteed to be unique. Alright, let's look at the example. So it says these are the different available gas at these stations, and this is the cost that it will this much gas I will need to move to the next station, and I will want to be able to complete a circle. So obviously we wanna that means that at first station I can fill up 1 units of gas, but I have to consume 3 units of gas to go to the next one. So I guess overall gain is what I am interested in, right? Right, and the overall gain will 1 - 3, which is -2. So that means I needed extra 2 units of gas from somewhere if I wanted to move away from the station. So let's quickly come to whiteboard and the example that is given to us. Let's take that. So gas is 1, 2, 3, 4, 5, and cost to move to the next station is 3, 4, 5, 1, 2, right? So we have to look at net gain, right? And we are want if the net gain is positive, only then we can start or move to the next guy, right? So here the net gain is -2. Here the net gain is -2. So net gain essentially is gas minus cost, right? This much gas I will fill, but this much I will give back to be able to move to the next guy. So all it means is that from whichever session I start, I need for this guy, I need at least 2 units of gas already, so that I can move to the next guy. Similarly for this, for uh, for for these two, I do not need any gas in my tank at all because I will be filling some, and then overall when I move to the next guy, I'll still save 3 after filling, right? So definitely starting from these two makes a lot of sense. Now, if I started from let's say the last guy, right? So I'll fill 3, and you can see there is a constant of cumulative sum coming in. Then I'll give up 2, so now I still have 1, and then -2. This is where the problem is. Now I'm stuck here because I need more gas, but I don't have to move further, right? So what we can do now is we can rely on this NAT gain, and we can build like a cumulative NAT gain as well. So cumulative NAT gain, right? Cumulative NAT gain building from this, we have -2, -4, -6, and then -6 plus 3 is 3, sorry, -3, and -3 plus 3 is 0. At the end, the cumulative net gain is 0. That tells us that the cycle is possible, right? So traversal should be possible if cumulative net gain is greater than equals to 0, right? But however, you have to figure out which point to start from. So I suggest what for that, you can simply see whichever point has the smallest cumulative net gain, in which case, in this case, it's this, travel from the next guy after it, right? So here, if you plot this, we have something like -2, -4, -6, and then -3, and then 0, right? So this is how. So who is the worst affected? Worst affected is this guy. So for this to be able to reach this guy or move further from this guy, you have to accumulate lot of petrol, lot of gas, right? And so whatever is the next guy after this, I'll start from this guy. In which case, which is this. So if we start from 3, I'll have accumulated 3, then I've accumulated 3 plus 3, 6, and then it will reduce. So 6 minus 2 will be 4, 4 minus 2 will be 2, 2 minus 2 will be 0, right? Basically, what I'm saying is, whichever is the least problem will be my last guy, right? And so if it has to be the last guy, then the guy after that is where I will start from. That's a simple logic to build. So let's use this concept. Come back to the code. So what I'm saying is we are maintaining uh, a min, right? And let's give it some largest value integer dot max value. We are also maintaining the index for that guy. Let's say -1. And now what we do is we go for each element. So I equals to 0 less than s dot length I plus plus. We're maintaining a cumulative sum as start with 0, and what we do is cumulative sum plus equals to uh, whatever the gain is, which is gas of I minus cost of I, and we are looking at the minimum that we get. So if minimum what we currently have, if this guy's cumulative sum is lesser than minimum, then you have min equals to cumulative sum, and the min index is equals to this index, right? And we keep doing that. And what we're saying is at the end, if the cumulative sum is less than 0, then cycle is not possible. Else, cycle is possible, but the min index is the one which has a like most negative effect, right? So this has to be the last guy so that everyone else can cover up for him. And so we'll start our cycle from this min index plus the next guy, and the min index would also be the last one. So we also do like percentile so that we treat it as a cycle. So that's the solution. Let's run. Let's submit. And it does work. Now, this is the approach that came to me intuitively, where we just keep track of cumulative sums and figure out which guy has the most problem, like meaning which is the most negative cumulative sum, and take the next one after that, and consider that as the last guy, and so that means that the next guy after it would be the starting point. Many people have used a slightly different approach, and I want to just talk about that as well. So the other sort of a slightly different way of looking at it is it's already sort of mentioned that it is guaranteed that the answer would be unique, right? So if we again go back to this guessed and cost array, what we'll sort of do is uh, okay, give me a sec. What we'll sort of do it is we'll start from the first guy, right? We'll start from the first guy, considering that as my start candidate. Obviously, the condition about whether or not a cycle is possible is just that the overall cumulative sum is 0, right? Which it is, but for choosing the start guy, one of the other ways to look at it is I will always consider, I'll start from the starting guy as the possible candidate. And but okay, if at any point the current gas becomes negative, right? So here current gas to start with itself is negative, then I will consider my next guy as a starting guy. And so then that means the current gas will become the gain that I get from that guy. And so, for example, I start with 0. It tells me, hey, I have -2, so it can't be a candidate anyways. Then for 1, I'll check 1. For 1, again, it's -2. It can't be a candidate anyways. For 2, again, it's -2. Cannot be a candidate. For 3, it's 3. So it can be a candidate. So I'll start from this guy as the candidate. And then, and again, 3 doesn't become negative. So the point is, starting from a candidate, like, let's take a different example maybe to clarify it further. So let's say the gain final, the gain that I get is, and gain is obviously gas minus cost, and we are really interested in the gain, right? To start with, let's say it's 10, and then this also gives you another 10, and then it's -10, and then -10, and then again -10, okay, and then 10. Let's say this is your gains, right? Now, from our previous approach, what we would have done is about the cumulative sum approach. What we would have done is we'll calculate the cumulative sum everywhere. So it will be 10, 20, and then, okay, and then it starts to reduce. So it becomes 10, 0, -10, and then 0. And we see that the most impact happens to this guy. So then I would start from next after this. I would start from this. That would be one of the possible things, and it works, right? So 10 plus 10 plus 10, 30, and then -10, -10, -10. It again becomes 0, and at any point, my overall gas net doesn't become negative. But that's about that approach. Now, another approach that we're talking about is this, where we consider my possible start as this guy, and we keep accumulating the gas. So one is we'll obviously keep track of the cumulative sum, and other thing we'll keep track of the current gas, and this is based on the start point. So initially they will be same because, okay, cumulative essentially means start point as this guy. So let's I will maintain cumulative, and I will maintain current gas. Okay, and initially my start is at this, so my cumulative becomes 10, my current gas becomes 10, no problem. And my cumulative becomes 20, current gas also becomes 20, no problem. Then here my cumulative becomes 10, current gas also becomes 10, then it becomes 0, 0, and then it becomes negative, right? And so that means when this becomes negative, there is a problem, right? We don't want it to be negative. So then the way to look at it is that means this guy will become negative if you start from anything before it, right? So then consider the next guy after it as a next start candidate, which is this guy. So now I consider this as the start candidate, in which case now my current gas will become what? The current, because I'm starting from here, my current gas will become 10. And cumulative is always cumulative. So cumulative is -10 plus 10, 0. And so you validate that, hey, my cumulative 0, so the cycle is possible, and my at the end of, with the current gas is positive. So whatever the last candidate that I considered for the start, that will be the candidate for the start. So let's look at that logic as well. All right, so we come back to the code, and so then I will just remove this code just and write code in that logic. So there also we are maintaining cumulative sum, so that is there. So cumulative sum is 0. Other we are maintaining is this current gas, and we'll start that to 0. And we are also maintaining start candidate, right? And this will be 0 to begin with. If it's 0 to begin with, then I'll start I equals to 0, I is less than gas dot length, I plus plus. So cumulative sum is simple. So cumulative sum plus equals to gas of I minus cost of I. And the same would be for this current gas. In the current gas, I will increase current gas A plus equals to gas of I minus cost of I. But at any point, if this current gas is negative, then I have to change anything to the left of it cannot be a start uh, candidate. So now I have to change the start candidate. So I'll do start candidate equals to the next guy, which is I plus the start candidate equals to, yeah, the current wherever I am plus one, and that is this, and also now this I will move to the next guy in the next iteration. So for now, let's set the current gas to zero, right? And when I increments, I will add the current the I plus one guys gas into it. So that's fine. And at the end of all of this, we'll do that if cumulative sum is less than zero, well, then it's not possible. And that could also be done earlier, which is here. So if cumulative sum is less than zero at any point, you could return minus one. So then you don't have to do it here. So if you're here, that means cumulative sum is greater than or equals to zero. So you have to return the start candidate, and that is it. So that's another approach. Let's see if it really works. Okay, we get a wrong answer. Let's quickly see why. Output is minus one, which is here. Oh yeah, my bad. The cumulative sum has to be the final at the end and not here. So if cumulative sum overall while going from the first to the last guy, if it is less than zero, then you will return minus one as you'll return the start candidate. All right, and submit. And it works as well. So these were the two different ways of looking at the problem. All right.